All right, so this is day 2 of notes for Unit 1, and this is a pretty short one. This is just looking at the geographer's tools, so the things that we use in geography. And so first off, and this is really simple stuff, first one's a globe, which of course is a 3D representation of the Earth. Of course, the best thing about a globe is that it doesn't distort anything, and so the sizes of the continents and things like that actually reflect the actual size of the continents on Earth as far as the ratio goes. But of course, it's not portable, and so that's where you have maps, which are 2D, and show you different selected parts of the Earth, and can show more detail than a globe. But the problem is distortion, which we'll get into in a little bit. But first off, you need to know what scale is and how maps are drawn to scale. And so really simple. Now you look at this one, the scale of this map is 1 to 3 million. Now the 1 to 3 million, that's inches. So that means 1 inch on the map equals 3 million inches on the ground. So when that number is lower, like 1 to 3 million, it means it's going to be zoomed in more, so you can see more detail. So in this case, we're looking at the island of Dominica in purple. And this is in the Lesser Antilles, which is the tiny islands that separate the Caribbean and the Atlantic Ocean. And then as we scale out, so now we're at a map of 1 to 15 million. Now I see Dominica there in the middle, but of course we're zoomed out more, and you can see all of the the Lesser Antilles in that region. And then we go to 1 to 45 million. Now you can see here's the Lesser Antilles. Dominica is right there, but now we've zoomed out to the point to where you can see northern half of South America, the Greater Antilles, so like Cuba and Jamaica and Haiti and things like that. So that's just what scale is. It's just telling you basically how zoomed in or zoomed out the map is. All right, then of course we know what maps are. So maps are great, but of course they're distorted. And so because you're taking a 3D planet, a 3D area, and putting it on something that's 2D. So if you were to think about Play-Doh, like if you were to look at this photo and imagine this was Play-Doh and it was stretched out, and if I had to push these edges in together, it would distort the continents on either end. They would be stretched out more than they should be, or what they actually are in real life. So that's the main problem with the map, is just the fact that the continents really aren't the real size it should be. So there's some different types of maps. Some of these you do need to know. Topographical map, you need to know what that is. Sometimes I'll refer to it as a topo map. But topographical map shows natural and man-made features. So a lot of times people will use these for like hiking. So they show you things like elevation of like mountains and stuff like that. And so engineers use these maps as well. And of course people who do surveying and stuff like that, they all use topo maps whenever they're constructing or building anything. And then navigational maps, you don't need to know every type of navigational map. These are mainly used for shipping. So you got the Mercator projection, the goods interpreted, Homo Listen projection, and Robinson projection, which is the more famous one. But again, you don't need to know the details of these projections. They're all just a little bit different as far as how they show the continents. But one thing you'll notice straight off the bat is how, like in this one, for example, Greenland looks close to the same size as South America. This is a great example of distortion. In reality, Greenland is pretty small and South America is huge. Keep in mind the U.S. can fit inside the northern part of South America. So you don't really see the true size of the continents on these flat maps. All right, and then another type of map we'll see is thematic maps. And thematic maps basically show different themes. So this map, for example, shows elevation. So you can see, the red areas is higher in elevation. And from this, we can, see things like, why people live where they live, based on like human population centers and stuff like that, which happens to be the next one. So this next one, the purple areas are where more people live. The white areas where people don't live. But of course, we know why. Like up here in Canada, it's really cold. You have the Amazon down here in South America, the Sahara Desert in northern part of Africa, and then you also have more desert in this area in southern Africa. You got Siberia up here throughout Russia, and then the highlands going in the Himalayas in this region, and Australia is mainly desert too. And so that's why population centers are where they are. It's because of the physical geography and what's around them. All right, then the Great Circle Route. This is used mainly by airline pilots and things like that. So if you're looking at a flat map and you're going to fly from Philly to Beijing, this would seem like the quickest route. It's always straight lines, always the quickest route. But in reality, the quickest route is actually this. It's what's called the Great Circle Route. So this line, which looks like a circle on a map, is actually a straight line on the Earth. And this line that looks straight on a map on the Earth is actually a circle. So it's the opposite. So this line here, this is further than this one here. You save yourself over 1,000 miles going this way from Philly to Beijing than you do going this way here. You'll see how it works here. So this line here is the line that on the previous map looked like a circle. You see it's actually a straight line from Philly to Beijing going over the North Pole. What looked like a straight line on the map is this one here, which is actually a half circle. This is further. This is not a straight line. So when you're on a map, especially for like pilots and stuff, they can't just fly what looks like a straight circle. The Great Circle Route is actually straight. So that can get a little trippy. All right, then a few other satellites and tools we use. You need to know the difference between these right here. You got Landsat, which are satellites that currently orbit about 100 miles above us, and they're constantly scanning the Earth. So if you've ever been on Google Earth or look at Google Maps or anything, most of those images are coming from Landsat. And then GEOES is the Geostationary Operational Environment Satellite. This is where your weather comes from. So if you ever look at weather radars, that's coming from GEOES. And then you got GIS, which is Geographic Information Systems. GIS basically, again, if you've been on Google Earth, you'll notice that there's different layers of information you can add in that you want to see. So, you can choose to see things like, I'm trying to think what you can see. You can see like animals that are in the ocean that are being tracked. You can see, of course, put roads on there, weather, things like that. There's different layers you can turn on and off. Those layers is part of GIS, Geographic Information System. So we can add and remove these layers on maps to see different types of things that we want to see. And a lot of companies use this as well to get information, like Walmart, for example. When they want to know where to build the next Walmart, they look at the Geographic Information System. Of looking at where people live, where they move, where they get around and stuff like that, and where would be strategically a smart place to put a Walmart. So this is used by a lot of different companies as far as planning and things like that. And then GPS, of course, you know what that is, Global Positioning System. This, of course, is what's on your phone and all that kind of stuff, telling you latitude, longitude, altitude, things like that. And, of course, how to get around is all GPS. So that's our basic tools. So that's it on Geographers Tools. Really straightforward and simple. Of course, big thing, understand map distortion, understand the Great Circle Route and how that works. And then these different types of satellites, you need to know what they are and how that information is used. So that's pretty straightforward and simple. You will see a lot of thematic maps also in the future as well. But that is basically it on this presentation. So I'll talk to you soon.